Wow, okay. Carboxylic acids. We're going to talk about those today. I want to talk a little bit later on. I'll talk about the lab report. I'm going to give you some time to work, probably on Thursday, to work on a lab report, quite a bit of time. But for right now, let's get the new stuff out of the way. Carboxylic acids are another type of organic functional group that can go onto a carbon chain, which we already know how to name quite a few things. We can do all the alkanes, all the alkenes, all the alkynes, and alcohols. All right, carboxylic acids, that's another type. It's got a new, different functional group on it, and it looks like that. Okay, it's this C double bonded O and then an OH over there. Okay, you want to write that in there because you probably don't have that general formula on your sheet. I told you some of these I did not put. Okay, so write that at the top because this one of the sections will be just match these things up with what they're called. So that would be a carboxylic acid. Notice it's similar to an alcohol. It's got the OH on it. But it also has this other group here, the C double bonded O thing. All right, that gives us some unique properties. Let's talk about first of all how we name these guys. Okay, well it's not hard. It's very similar to what we've been doing before. You're going to name the alkane and all that implies. You're going to add an OIC suffix and then the word acid. That's basically it. And you actually don't even have to number anything on here because if you notice something about these guys, where will this kind of a group have to always show up? Can I have this in the middle of a chain anywhere? No, because I'd already have 1, 2, 3 bonds taken care of from just that group. All I can have is one more place. It's got to be at the end of a chain. Do you understand? Like, let me just, for those of you who don't, let me just show you. I can't very well have this. Okay, does that make any sense? No, for a couple of reasons. H can't be bonded to two different things. So say, okay, well, I'll do it this way. I'll do this. I'll go up here. Why can't I do that? Now I got 5 bonds around carbon. Okay, so this group's always going to be at the end. And let's show you that with a couple of examples. Okay, start with the easiest one. What would this guy be? What would his name be? Methanoic acid. That's it. Methanoic acid. Not methoic, but methanoic. Methanoic. Now, I do have to say something. For each of these, I'm going to give you the common name of them, not just the UPAC name. That is the way you would name them, all right, on the test. However, we're going to be doing a lab either, not exactly sure when, because of the crazy schedule. I won't be here Thursday. I have a doctor's appointment. Tomorrow, we only have a single period. Probably won't get to this lab until Friday. And even then, we'll have only a single period to do it in. However, when we do this lab, we're going to be using these acids. We're going to have on those bottles, you just don't buy a bottle of methanoic acid. It will say it on there somewhere. But most of it, and the largest name of it, is probably going to say formic acid. Okay? This is one of those guys that they use a common name for more than they use the actual systematic name. He's not the only one. I'm going to put the 3 acids I'm going to put up here are going to, on the bottle, be labeled with their common name. Okay? That's one of them. And by the way, formic acid comes from, original derivation of formic acid, where you would get it from, was destructive distillation of ants. Why? Think about it. What do ants do? Fire ants, if they bite you, they burn, right? You know what they secrete? Formic acid. Yeah. So if I boiled ants, not uncles, but ants, but no, I'm serious. That's what you can actually get formic acid from that. You just boil it and recondense it on the other side. Instead of, like, what do? We boiled water and alcohol mixture, and we got alcohol on the other side because it boiled lighter. Well, formic acid will boil off first. All right, another example would be example 2. Another very familiar one to us. That guy right there. What would his systematic name be? Ethanoic acid. God bless you. He has an even more common name to us. He's something that we're all familiar with. We actually put it on our food. We preserve things with it. What acid do we have in, not citric, no. What acids do we have in pickles and French fries and salad dressing? Vinegar. Yeah, vinegar is acetic acid. Acetic acid or vinegar. Now, vinegar is actually a dilute solution of acetic acid. Acetic acid is the common name of ethanoic acid. So all these names for the same thing. You may have heard of acetic acid. You certainly have heard of vinegar. All of those, both of them, are basically ethanoic acid. And the last one you're going to use in this lab, okay? The reason I'm putting all three of these up here, obviously for a little bit of practice, but there's another reason. The other one we're going to use in the lab is I'm putting up here. And this guy will be called butanoic acid or butyric acid. Butyric acid, well, you got to stay on my good side at least for the next couple of days, because if you really tick me off, you'll be the group that has to use the butyric acid. Butyric acid has an incredibly horrible smell. It actually comes from it's what's present in rancid butter, and will cause projectile vomiting if ingested.
Awesome.
Yes. Not that you're going to want to drink this. Trust me. It's going to smell. Well, imagine taking like an old sweat sock that you haven't washed and played, basketball in for a week, and you put some cheese in that sock, and you wrapped it up, and you put it in the basement under some dirt for a while, and then you dug it up. That's what it would smell like. And it is an amazing thing when you do smell this, because you will in the field, but thank God. When you smell this, it'd be like, this is a clear. It looks like like water. That's how clear it is almost. It's a little thicker than that, but it looks like water. And yet it smells like something that died twice in something else that died. Yes. What does this say? What do you think butyric acid says?
No, I wasn't sure how to say it.
I know that. I know. That's why I'm making fun of you. What do you think that letter is that you probably can't figure out?
What? Is it
Well, because. What letter do you think that is?
why?
Because. Get it? Why?
Is it a Y or not?
It's not a knot. It's a Y.
Is it a Y or not?
It's not a knot. Does it look like a knot? Here's a knot. Okay? I mean, that's a knot.
Okay, is it a Y or is it is it not a Y?
Ah, there we go.
Are you happy?
It's a Y. What other letter could this possibly be?
A G. A G.
Yes, butyric acid. That's exactly how I pronounced it. I can see why you would think it would be butyric acid.
Yes.
Yes, that makes sense.
Well,
Complete sense to me. Which is why I originally was making fun of Olivia, not knowing if that was a Y. But thank you for allowing me to make fun of you too.
It didn't. You didn't say it had to make sense.
All right. Now let's go on to properties. Properties of carboxylic acid. Well, as you can imagine, carboxylic acids are weak acids. Get that weak acid out. Get that weak acid. Yeah. You guys are a pain in the ass. It's a weak acid. A little bit of a review of our our inorganic Chem 1. There's going to be quite a bit of review today of Chem 1 concepts here. One of which is acids and bases. I've done this several times. Now, don't worry, I'm already planning this. I've already begun doing stuff for it. Before the actual AP exam, we will have a long review, like a couple of weeks. As much time as I have at the end of the year is how much time we will review before the actual exam. And as part of that, I will be going over a lot of the concepts, stoichiometry, which we had to talk about again as part of the fermentation lab, acids, bases, even periodic table concepts, which most of you know, but I'm going to go over all that again. Like if I ask you what the charge of calcium is, you know it, but we're going to go over other things about size and ionization energy, electronegativity, things like that. Well, one thing, a little review here for acids. We had two ways to define acids back in Chem 1. Guys who donate H's or form hydronium ions in solution. And this was the Arrhenius version of the definition, and this was the Bronsted definition. Okay, there's actually a third one. We'll talk about that one as part of the AP curriculum as well. It's called the Lewis definition. All right, but I only kind of, for Chem 1, we kind of kept it simple. All right, Well, that's what these guys do. They will donate that hydrogen and act like an acid. Some of you guys act like acids. All the time. Okay, that's one major property of a carboxylic acid. I don't think anybody would be surprised by that, but you'll have to know whether something... We're going to talk about organic compounds that are bases. And they, of course, will accept H's or form hydroxide ions, one or the other. And you have to know the difference between them. Those are guys that are called amines, and this guy is a carboxylic acid. Know the difference between them. Also, you'll find that the carboxyl group is very polar. Since he's polar, he'll dissolve in water pretty well, at least the low molecular weight ones, which means the low molecular weight means the small ones, the ones that don't have a lot of carbons in them, the ones that aren't so heavy. The more carbons I have, of course, the less likely they're going to be to dissolve in water, because the greater the non-polar portion of that molecule. Okay? All right. Now, having gone over now how to name them and their properties, let's talk about how we would make a carboxylic acid. Preparation reactions. And this is, you're going to get some that you just have to look at the general formula for oxidation of a primary alcohol in this case. You look at the general formula, and I will give you a specific example, and you'll simply do it. All right. Other times, I'll say, make this carboxylic acid. And by the way, yours does not have, yours is filled in, I believe, correct? You should have like that here and that there. Is that right? Yeah. Okay. All right, let's do an example of this guy. Let's take a very simple one. And that's all I'll give you on the test. You have to remember this. That's all I'm going to give you on the worksheet today. You're going to get a worksheet today, handout number 3. All right? You're going to have to finish this, not in class today, but you'll get a chance to start it on today. I won't expect you to finish it for homework, because there's one problem I won't get to do. But if I gave you this guy on this worksheet, and sometimes I'm amazed by how, when people get these, they just don't understand. What am I supposed to do here? They make the same mistakes over and over again. Look, every time I'm doing one of these on the board, which that's all I've kind of been doing, besides the demos and the interruption of the lab last time, all I've been doing is doing a specific example of each of these general formulas. So your job, I know you're going to have to start looking for throughout. You know how many we're at now? 17. By the end of this period, we'll have covered 17 of the reactions on this sheet. I know you're going to have to find which one it is. But once you do, once you say, okay, I'm taking a primary alcohol, you know what primary means. Primary means he's on an end carbon. If I have an OH here, it won't work. I cannot get, with potassium permanganate, I cannot get this guy to turn into a carboxylic acid. It has to be on the end. Okay? What will I get from this? Well, I hope everybody knows that I'm going to get this from this. You all agree? Right? Just looking at the general formula, that's what you're going to get. I hope you can all name the guy on the left and the guy on the right. What would this guy's name be? Over here. Yes, you do need the name, the number, I mean. And this guy over here would be, do I need a number over here? No, not really, because he can't be in the middle. So this guy would just be propanoic acid. And there you have it. Now, there is something that I'm going to mention to you, because there's a little NBR next to all these. Not to all these, but to a couple of these. Okay? What do you think the NBR stands for? What is this guy, if you look at him, there's something wrong with it. What is it? It's not balanced. And this NBR, I'm telling you on a handful of these. This is one of them. I don't want you to worry about balancing these. The oxidizing agent is potassium permanganate, which I'm going to show you in just a minute when I'm done with this notes on carboxylic acid. I'm going to do a demo for you in a few minutes. And it's pretty cool. But I don't expect you do not have to worry about balancing this. Just know that the potassium permanganate does provide the oxygens for this to happen. I have more oxygen over here than I have over there. Where that came from, all right, is the potassium permanganate. We don't have to worry about balancing it in this case. Okay? There are times when we do balance these. We call them redox reactions. You did that last year. Remember the end of last year we did redox? They get too complicated to worry about for now. Okay, we're just going to we're concentrating here on the naming and the writing and the completing and the synthesizing of organic compounds. I don't really want you to worry about that kind of balancing. The easy balancing, there's a few of them that need balancing in the organic you do have to do. All right, now let me take a second here and show you what I'm going to do in my demo over there, because it's really a pretty neat demo. If I take, don't copy this guy down. You just did your example, all right? If I take glycerol, or glycerin, same thing, glycerol, glycerin, which I used once before to make my soap bubble. Remember my propane soap bubble, or methane soap bubble? If I take glycerol, that's what glycerol looks like. No surprise, glycerol ends in OL, and it contains alcohol, OH groups. If I take him and I add potassium permanganate to him, which I'm going to do, you don't need to write this down. What I will do is he will react with that, kind of in a neat way. I'm going to do him in the fume hood in just a minute. Okay, I'm going to do that in a few minutes, just a minute. But I want to finish the last reaction on this guy before I do, while I'm still running, and the camera's actually working for 5 minutes here, although it is a little crooked. But sorry. Okay, reactions of carboxylic acid. Let's talk about those. Let me straighten this guy out a little bit. Reactions. Well, first of all, we can reduce this guy into an alcohol. I don't even have an example of this guy, and I want you to see why. Why don't I have an example of this guy? Well, no, because what is he basically the exact same thing as? The reverse of the one we just did, isn't it? In the one I just did, I took a primary alcohol, and I turned them into a carboxylic acid. Here, I'm taking a carboxylic acid, and I'm turning it into a primary alcohol by using a reducing agent. A reducing agent is going to provide the hydrogens, lithium aluminum hydride. All right? And again, I'm not going to ask you to worry about balancing that, but that's what's happening there. It says MBR next to that one as well. There aren't many that say this, about 3, and 2 of them are on this sheet today. Okay? And I don't have room for an example because I think you don't need this as an example. The one at the very bottom, also, you're going to say, well, why not I going to do an example of that one? Let's take a look at him. Conversion into esters. Whoops. Conversion into esters. Now, for this guy, all I want you to write down, then I'm going to start to do my little demo over here. All I want you to write down over here is C ester preparation. C ester prep. When you, in a minute, after I'm done, I'm going to shut the video off, I'll do the demo, and then I'm going to start esters. It doesn't make sense for me to show you this reaction now, because you don't even know how to name esters, you don't even know what they are. But the second reaction we could use carboxylic acids for is to make an ester if we react it with an alcohol. As you can see from the example down there below, right? I mean, isn't this what your thing looks like? Kind of looks like, oh no, I can't do that right now. I'll come back to that in a minute. Let me just shut this off, and that's